Hello, my name is William McKillop, and this is Lab 1 of Physics 2212, Charge Tape. So, in this, we'll be talking about the main ideas, the use topics, the results, and additional notes. So, in the main ideas, this lab focuses on charged particles and their interactions with other charged particles and neutral matter. We were also expected to find the amount of excess charge on one piece of tape. So for the topics, we have Coulomb's law, which is force equals 1 over 4 pi epsilon naught times q squared over r squared times r hat, and Newton's third law. So quick look into the results. The tape is negatively charged. The two charged tapes repelled each other when in a close enough proximity. Attracted to neutral matter, repelled negatively. So the tape has a charge of 6.07 times 10 to the negative 9 coulombs. And tape has 3.79 times 10 to the 10 excess electrons. So here are some notes and assumptions. The system in this experiment was the charged U-tape and the objects that it was interacting with. Air resistance and other external forces can be ignored due to their insignificant effect on the results of the experiment. Assume that the charge is evenly distributed throughout the tape and that each charge is the same for each U-tape. So here are our initial conditions. We have length, mass, separation distance, force of gravity, electric force, and I measured these things and then I converted them. As you can see at the table, the far right are the conversions. And here's a little illustration of how, this was calculated and how it went down. All right, so for our calculations, we have force of gravity, and we found that to be 0.002 newtons after some conversion. And the electric force equals the force gravity. And so we use this to find Q, which is 6.07 times 10 to the negative 9 coulombs. And we have additional calculations like the number of excess electrons, which is Q over the charge of an electron. Found that to be 3.79 times 10 to the 10 electrons. We found the area of the tape, which is a simple length times width, which comes out to 0.0038 meters squared. And the number of atoms on tape, it's just a simple conversion here. And it's 3.8 times 10 to the 17 atoms. Next, I did the ratio calculation, which turned out to be 9.97 times 10 to the negative 8 electrons per atom. And the ratio of excess electrons to number of atoms came out to be 9.97 times 10 to the negative 8 electrons. So here's my glow script. So we have two pieces of tape as point charges as illustrated on the top left. And the orange arrow represents the gravitational force, while the green one represents the electrical force. And I have also attached the code here of how I achieved this. So the sources of error in this experiment, they're the same as the assumptions made earlier. So we ignore all external forces and assume that the charge is evenly distributed throughout the tape. Also, we consider the charged tape as a point charge when it is more like a line charge because there are multiple charges on the tape. So here are our final thoughts. What if the electrons were positively charged and protons were negatively charged? So the experiment/observations would not change because a positive and a negative charge will still attract and like charges will repel, like a negative and a negative. So the why question I answered here, the difference between point and line charges comes from experimental error on glow script. In terms of real world scenario, line charge is a better and more accurate value because tape itself is not a point charge.